Hey everyone, welcome to this video. It's Kyle. Today we're going to be talking about authentication. Our goal by the end of this will be to have an understanding of a simple authentication flow, the difference between authentication and authorization, as well as how to protect our information, and the beginning comprehension of encryption. So before we dive into this, let's talk about a situation. Say you're given a bag of candy to protect, and you're surrounded by a hungry crowd, but you only want to give some to your friends. And to make matters worse, you're blindfolded. So you don't know who's asking. Sure, some people can come up to you and say that they're your friend, but you don't know for sure if they are because they could be pretending. So you put them to the test. You make sure your friend knows your secret handshake, knows your favorite color, or ask this person to prove they're your friend in some other way. This is the same with authentication. We are asking, who are you, and prove it. But instead of a bag of candy, we're usually protecting financial information, important documents, private websites, and more. So instead of telling people to prove they're our friend by knowing our favorite color, we use something more substantial. We have to ask our users for secrets that they will only know to verify it's them. The most common secret is a password, a set of characters, numbers, and symbols, all arranged in a pattern that only the user knows. A second example would be using a device we already trust to verify it was you. When logging into a website, you might have seen this on your phone where it asks you, was this you who just logged in? A third one that's becoming increasingly popular is called physical, using our fingerprints or faces to provide that secret to tell people we are who we say we are. So when we're trying to gain access to documents or other information that's restricted or protected, we need to use our secrets to verify our identity. This is called authentication. Another word you might have heard is authorization, though which sounds similar to our last concept is fairly different. Authorization is when someone has already verified their identity, then based on that identity, they're given access to websites or information that they're allowed to see. For example, if a school has a website that teachers and students can go to view and edit grades, if a student logs in with their username and password, they're able to view their grades. However, they're not the teacher. Therefore, they're not allowed to edit the grades. Hence, they're not given the authorization to. So great, we now know what it takes to authenticate a user and the difference between authentication and authorization. But how do we do it? Picture a user that wants to gain access to restricted information or a restricted page. We know between this user and this restricted information sits our server. And as we've mentioned previously, the user has to provide a secret that only they know to us to verify it's them. It then goes to our server. We check this information against our user table. If there's been a mismatch or we didn't find them in our user table, we have to let our user know that we don't know who they are. However, if we do find that their username and password are correct, we allow them access into the page or provide them back that restricted information. Now let's take a closer look at the interactions that are happening. When our user, our client side, starts a conversation with our server by opening our website, our server, or server side, creates a session. A session is an interaction between a computer and a user used to exchange and remember information about what happened. All of this information is remembered in key value pairs. Examples of some of this data that is remembered: our user ID, or maybe our IP address to help identify us, shopping cart information, or which pages we spent the most time on, those important interactions between our user and our website. Finally, our session ID, which is created when the session starts to help the server identify which session we're talking about. Don't forget that one server could be hosting thousands upon thousands of sessions at one time. Finally, all this data that's being remembered by the session is only temporary. In the end, this session will be torn down, and therefore all this information forgotten, of course, unless a server saves anything to a database. Moving on, once a session has started, the server sends that session ID back to our client side, so we can use it for later. But how do we save it? We remember this information in an object called a cookie. These are small bite-sized packets of temporary information, saved in key value pairs as well, on your browser. It's important to save the session ID inside of a cookie because when we're communicating with our server, we need to send the session ID in every request we make so the server knows who it's talking to. This is how we can remember if a user signed in before, or possibly what they want to see on our website. Other information that cookies can hold is also personal information, our first names, last names, or emails, so that sometimes websites can autofill information in for us or personally greet us when we come back to the page. Another is preferences. How did we want to customize our website? What content do we want to see? That can also be saved in a cookie. Since we now have that understanding of how authentication works and how our interactions take place, let's turn our focus to our users. One very important piece of this flow is the user table. It's how we remember who our users are and that very important secret we use to verify them. We have two columns that might be obvious. The first one is the username, where a user provides a set of memorable characters and numbers for them to use to log in. Sometimes it's an email. And then we have our password column, where that secret is stored. Now, looking at this table, what would happen if a hacker got access to our database? Our passwords in the password column are completely exposed. The hacker then has access to every one of our users' accounts instantly. Therefore, it is absolutely critical to never store your passwords in their complete form in the password column. It's our job to protect our users' secrets. We have to provide some security. And to do this, we need to encrypt these passwords. Encryption is when we take a document or some kind of information that we can easily read and jumble it up in some way to make it completely illegible. That's exactly what we're going to be doing here. And the first type of encryption we're going to talk about is called two-way encryption. This is when we take that information that we want to protect and we choose a key. A key can be a set of letters, numbers, and symbols that only we know, and we pass that key and this information into an encryption algorithm. That algorithm is going to do the jumbling of that information to create a new document. That encrypted text in that document now can be stored anywhere securely, knowing that anyone who gains access to it cannot read it. But the special thing about this encryption, we can take that encrypted document, pass it another key, use a decryption algorithm, and recreate the original information. Two-way encryption is a great way to send personal or private information across the internet. However, it's not a great way to store passwords. So the second type of encryption we're going to talk about is one-way encryption. This method takes information, uses an encryption algorithm to jumble up the text once more into a new encrypted document. But the catch here is that it cannot be translated back into the original information. It stays encrypted. One method we use to do this is called hashing, which will be very important for us when we're trying to protect our users' passwords. This is because we can take our user's password and hash it into an illegible string of characters, symbols, and numbers. Now, important things about hashing algorithms, it should not be able to be easily deciphered. It should also be deterministic. Putting in that same string every time should always produce the same hash. Then finally, these hashes should be unique. So using this process, when a user signs up with their username and password, we can immediately hash the password and save it into our user table as that hash. Therefore, our user secrets are no longer vulnerable to a hacker. So now that we have the hashes in our user table, when we want to authenticate a user, the user will still type in their username and password exactly the same. That username and password will then be sent over to us, and we'll immediately hash the password. Once we hash that password, the hashing algorithm has to be repeatable. So whatever password they typed in, we can pair it to the user table to see if the hashes are the same. If they are, the user's been validated. If the hashes are different, we tell the user they could not be verified. All right, so hashing is awesome, but let's talk about some possible complications with it. Say we have a password that gets hashed into that super secret code. However, say we have another password that a user creates, it gets hashed, but the hash comes out exactly the same as my previous password. The passwords are different, but the hashes are the same. This is called a collision. Though it's extremely rare, it's something to be aware of. Another potential problem is that if a hacker gains access to our database and finds all of our hash values that we've saved securely, there is a chance that these hashes can be reverse engineered into the original password. This is called reverse engineering. And how we protect against it is salting our passwords. Salt or salting is when we append a randomized value to the provided password. Then once we attach it to the password, we hash that entire string, giving us a completely different hash code. So the best thing about salting is that this salt value is not a secret. So in our user table, we add another column called our salt value, which we save that randomized value that we've created when hashing into our table. So when we're trying to authenticate a user, we take their username and their password like before, but before we hash, we append that salt value to the end of their provided password, hash it, and then compare that new hash code to the one stored in our database. So that's it. At this point, you should have that basic understanding of what authentication is and the flow of how we authenticate a user, the difference between authentication and authorization, as well as how to encrypt and protect our information that we're storing in our user table. And I want to thank everyone for watching.